Hello everybody. Today we are going to see Unit 9 Physical File Design and Database Design. So, without wasting any more time, let's straight jump to the introduction. Once the logical system design has been finalized in consultation with the user, the details of physical design of the system can start. Physical database design involves actual implementation of the logical database in the DBMS. The requirements of physical design of the system require the logical design of the system. The database design involves three levels of design concepts, namely conceptual, logical, and physical schemas. Conceptual model produces a data model which accounts for the relevant entities and relationships within the target application domain. Logical model ensures via normalization procedures and the definition of integrity rules that the stored database will be non-redundant and properly connected. Physical model specifies how database records are stored, accessed, and related to ensure adequate performance. A good database design helps efficient storage and retrieval of data. Objectives. After going through this unit, you should be able to understand the advantage of databases over files, difference between logical and physical design, rules for good database design practices, define the concepts of fields, records, and database, how to design the fields and records in a database table, understand various constraints enforced during database design, typical database design concepts, and explain the concepts of records, record types, and files, as well as the different techniques for placing file records on disk. Then comes Introduction to Database Design 9.2. Over a period of time, massive advancements have taken place in the field of databases. Storage of data and retrieval is an integral part of any information system. Flat files versus database. Traditionally, data are being kept in flat files. Consider an example of flat file which stores pin code of customer's address. Any change in the size of the field will enforce changes in the entire program, which uses the data related to customer's address. If the file is being used by more than one application, the problem can become even worse. Steps in database design. Analysis is the process of creating a conceptual data model independent of the target database technology. The typical result is an ER model. Design is the process of creating a logical data model. This step is dependent on the target technology, relational, hierarchical, or network, but not on the specific database implementation, such as Oracle MS SQL DB2 for OS by 390 or DB2 Universal Database. Implementation is the process of creating a physical model or schema for one specific database system, such as Oracle, MS SQL, DB2. The result is an optimized physical design. Model to database design. The process of database design process involves the task of converting logical model to working physical model. The logical model can be arrived at by the application of normal forms. Normal forms are nothing but a set of rules applied sequentially starting from the basic table to the table resultant due to the application of a normal form. As of today, there are a total of 5 normal forms. The first normal form is applied to the basic table The resultant table is given as input to the second normal form, and so on. It is not mandatory to continue this process until the fifth normal form. Usually, the process is continued until third normal form. Fourth and fifth normal forms are applied only when there are multi-value dependencies and joint dependencies, respectively. We are not introducing you to the normalization theory in this course. It will be dealt in the course related to databases in detail. Physical database design starts from a given relational model, that is, from the definition of a set of tables and their respective columns. The objective of physical database design is to fulfill the performance requirements of a set of applications by optimizing the use of the DBMS. Key areas include optimizing the index configuration, data placement, and storage allocation. Entities with one-to-one relationship should be merged into a single entity. A table models each entity with a primary key and non-key attributes, some of whom may be foreign keys. One-to-many relationships are modeled by a foreign key attribute in the table representing the entity on the many side of the relationship. Many-to-one relationship between two entities is modeled by a third table that has foreign keys that refer to the entities. These foreign keys should be included in the primary key of the relationship table if appropriate. Many commercially available tools can automate the process of converting a ER model to a database schema. Figure 9.1 depicts various steps involved in the design of databases. Enterprise modeling, conceptual data modeling, logical database design. What happened? Logical database design, physical database design, and database implementation. So these are the steps in database design. Inputs to physical database design. Logical structure of database, normalized relations, definition of attributes, data type, integrity control, error handling, choice of RDBMS, hierarchical, network, relational, DB2, MySQL, object relational, Oracle 8i by 9i, estimation of database size, growth rate, and frequency of usage, requirements for backup, recovery, response time, and retention time. Guidelines for database design. The following are various guidelines for database design. Ensure that the data stored in the files database tables are atomic. Data stored in the atomic form can be combined later to generate data in specific form. Every table must have a primary key which identifies each record in the table distinctly. Descriptive and meaningful name is to be used while naming a field in the table. For example, use product underscore ID instead of ID. Use single column primary key whenever possible, as most of the join operations are made on primary key and composite primary keys make the operation slower. Use numeric key whenever possible. Use primary key name as foreign key for better readability. Avoid allowing null values to go into the columns that have discrete range of possible values and avoid multiple tables with similar structure when one table is sufficient. Depicts 9.2 figure depicts various records and fields in a file which consists of details of various employees in a hospital. So here you can see records and fields. So here we come to the end of part 1, and till then keep exploring.